So we were discussing about the frequencies and polarization, right? And we had seen the RHCP and LHCP, okay? Left hand, right hand circular polarizations, and how we try and get them in odd and even format. And once it's done, uh, we get additional space, and due to which we are able to work out in a much better way. Okay, the reason why we do that is because we just have about 32 transponder channels, and we have only about 500 megahertz. So in order to make this efficient utilization, as you all know, bandwidth is very precious. Okay, and we cannot afford to leave it unused. Okay, so every bit of it needs to be utilized. So hence what we do is we try to make the best use of the available bandwidth. So this is possible only when we try and change them in odd and even format. You would have seen this in your previous modules, right, as to how this was done. Okay, so the same concept is applied here, and we go ahead in getting few megahertz, okay, saved just because of this odd and even concept. So as you all know, there are different types of satellites based on their power requirements: high power, medium power, and low power. Okay, so those three are the main types of transponder power utilizations. And here you can just check. Okay, there is few information as to how they are separated apart by about 9 degrees, right? Okay, and how they are connected with respect to North Pole. And as of now, okay, how much of information is available, or how much of services are being provided by these service providers or these different companies. Okay, so power rating, as I told you, it's basically dependent on what kind of information that you want to transfer. Okay, is it something where you do not worry about the utilization of power? Okay, so in that case you can use your uh, high power satellites. Then in your medium power satellites, something, okay, which is as equivalent as your high power but a little less than those. For example, you can see here in your uplink we are using the ranges from 17.3 to about 17.8, right? Similarly here you can see that we're not going up to about 17, but we are using about 14 to 15 gigahertz range. Okay, and as I mentioned previously, your downlink frequencies will be less compared to your uplink. Okay, can someone tell me as to why is that? Why is that downlink frequencies are lesser than uplink frequencies? Is there any specific reason for that? Yes.
Sir, to avoid interference.
Okay, to avoid interference, Pranay, but there is something else more than that.
Sir, to reduce power.
Not only reducing power, the effort needed to transfer signal from the base station to satellite is higher. So I cannot afford to send lower frequency signal, because by the time it reaches, there can be some interferences, and ultimately the signal is lost. Okay, so the purpose of communication doesn't happen. So that's the reason what we do is we try to have the uplink frequency at a higher uh, rate, okay, than the downlink, and the effort required for signals to come down. Okay, gravity also plays an important role here. Okay, so due to which your downlink signals are having lesser frequencies. Okay, so this concept is to be understood. Okay, and guard band here. So the effective guard band is about 24 plus 3. So 3 is your guard band, 3 megahertz. So when we calculate, when we add 24 to this 3, so the effective frequency range or the bandwidth is going to be about 27 for each transponder, right? So these are the ranges that you can see for your RHCP and LHCP, which is the uplink and downlink. Now, if you can see these ranges, you can easily get to know that these are actually high power satellites because it's having about 17 gigahertz. Okay, so if you can see these ranges, 17 gigahertz is only for high power satellites. For medium power, it's about 14 to 14 and a half. Okay, right. Okay, then we discussed about the DTH, direct to home services, and one important concept that we spoke about is compression, right? So how can compression play an important role? Yes, Kishan, how can compression play an important role?
Sir, compression will help us reduce the
Good.
size of bandwidth we are using.
Okay. So due to which, what is the advantage? Is there an advantage or disadvantage?
So we can use more of a bandwidth, like we
Correct.
can consume less bandwidth for a particular signal.
Correct. So each signal will be able to accommodate in a much lesser space. Okay, if we try to compress them, provided we also have an eye on the quality of signal. Okay, so even that needs to be taken into consideration, right? So signal compression plays a very important role where we can try and accommodate many signals with the allocated range of frequency that is given, which is about 500 megahertz. So in that, I'll have to accommodate many information signals. Now, even noise signals do accommodate this bandwidth. So as much as possible, we try to make sure that we do not have much noise and only the signal is accommodated in the given bandwidth. Okay, so due to which with my given bandwidth, I can effectively use it for transmitting not only signals but good signals, and I'm not interested in transmitting noise signals. Okay, I do not want to invest for noise signals. So that's the importance of a signal compression, right? So as we have also seen, it's not a simple process, but then it's a very complex process where a lot of algorithms are employed. You can actually design a filter with the help of MATLAB. You can use the toolbox and you can design a filter. You can write a code accordingly, and you can customize your filters accordingly to your requirement, and accordingly you can actually go ahead with this signal compression techniques. I cannot say that there is just one compression, but if you just browse through the digital content online, okay, you can find that there are n number of techniques. Now, each technique will have its own pros and cons. You'll have to decide as to which is good for what purpose. Okay. So based on that, you can actually decide, and you can come out with a proper solution as to which can be employed. Okay. So the next thing that we'll be looking into is your transponder capacity, and we have a formula for this. Okay. To estimate the bit rate that can be carried in a 24 megahertz. Now remember, this 24 is without the guard band. Okay, so we are considering only the information signal, okay, which is about 24 megahertz, can be determined as follows. So the estimate bit rate as to how much of bits are being transmitted each second. Okay. So if my system is good, if there is no much noise, if there is no loss, then gradually I can actually increase the bit rate. See, the same thing is happening with your generation of networks. If you compare your first generation to second generation, okay, first generation of telecom networks were used only for calls, right? You didn't even have the SMS facility. But then as you migrated to the second generation, okay, the SMS came into picture. And we even got low speed internet, okay, which is GPRS. Then after that, with 2.5 and 2.75G, we moved on to something called Edge, right? And the transfer rate was high. How was it possible? Just because of the bit rate. Okay, so since the bit rates were high, we were able to move on to a different technology. And as you all know, there was a migration that happened in 2010, right? In 2000, which is 3G. And then 2010, we moved on to 4G. And then now 2020, we are in the verge of having or experiencing 5G networks. So as you can see, every 10 years, there's a major change that happens in the technological world, wherein, the transfer rates, the bit rates are increasing. So that's the importance of bit rate. So if your data can be transmitted at a higher speed, okay, then you should have supporting circuits that employ this facility, right? So if I have to find out the bit rate of my system, okay, of my transponder, then I'll be using this formula, which is RSIM, okay, which is symbol rate is equal to BIF, okay, which is nothing but your intermediate frequency divided by 1 plus rho. So the bandwidth of 24 megahertz, and we have a roll-off factor. Okay, so this rho is nothing but your a roll-off factor. So generally, okay, generally this is kept constant, okay, which is about 0.2. Sometimes it will be mentioned in your problems. Consider roll-off factor. Okay, so in that case, you can take the values directly from the question. Okay, and the bandwidth. Okay, bandwidth will be about your 24 megahertz. Now, what is the symbol rate? Okay, so find the symbol rate. So all this information is there. So you have the value of BIF. Okay, you have the value of 0.2. So now it's very easy for you to just substitute and put in the values. Okay. So you can find out R symbol or symbol rate. So that's the question asked, find the symbol rate. Satellite digital television uses QPSK type of communication, okay, which is quadrature phase shift keying. And we know that M is equal to log 2 M. Okay, so if we use M is equal to 4, okay, here if we substitute M is equal to 4, okay, then we will be this is actually base 2, okay, this is actually base 2, so we will be getting M is equal to 2. Okay, so if 4 is substituted here, so you can do the math. Why are we doing this? Bit rate. Okay, now our bit rate, we have a different formula. This is your symbol rate, and bit rate is RB is equal to 2 times your symbol rate. So which means once I have this value, once I have the symbol rate value, okay, I can multiply it with 2, then I'm going to get my bit rate. Okay, so I hope you have understood the formula. So can I move on to the next slide? Yes.
Yes, sir.
Fine. So this. So this bit rate, okay, that you can see here is 2 times your symbol rate, and in order to find out symbol rate, then you have this formula here, right? So let's take this as an example. Okay, your symbol rate, which is 24. Okay, why is it 24? Because BIF is equal to 24 into 10 raised to 6, why 10 raised to 6 megahertz divided by 1 plus, and your roll of factor was about 0.2. Okay, so I'll be getting about 20. Okay, uh, so my R symbol is going to be about 20. Now RB is equal to 2 into your whatever symbol that you have received, okay, twice. So this is going to be about 40 Mbps. So this is how you calculate your speed of your bit rate. Okay, so this is the bit rate that can be carried in 24 megahertz channel using QPSK. Now most of our internet connections these days, okay, are about 100 and 200 Mbps lines, right? So if you want to enhance this, okay, then you will have to move on from 24 megahertz. Okay, so you just cannot be in your 40 Mbps line these days. Actually theoretically, can someone tell me what is the theoretical speed of your 4G networks? I think you're extensively studying wireless communications, right? So the theoretical values of your 4G speeds, can someone tell me?
Nearly 350 Mbps.
No, I'll tell you. You should be getting 100 Mbps if you're moving at a speed of 100 kilometers per hour. Understood? Say you're sitting in the train, okay, and the train is moving about 100 kilometers an hour. When you do the speed test, you should be getting about 100 Mbps when you're moving at a speed of 100 kilometers an hour. But if you're constant, okay, if you're constant, you should be getting a speed of about 1 Gbps. Are we getting it these days? So theoretically, this is the value that we should be getting, but practically it sometimes becomes difficult, okay, because of the type of modulation, the loss factor that happens, the noise that gets added. It can be with how far you are from your cell, okay, and how good is your link. So all this plays a factor, and the environment, okay, the atmosphere. So all these has a major role to play in your speed. So these speeds are actually achievable in our 5G networks. So which means whatever we saw theoretically, those speeds are attainable. Okay, so we are able to achieve those speeds in 5G networks. Okay, fine. So this is how we actually calculate the speed of your transponder capacity, okay, the bit rate, right? So I hope these concepts are clear, right? This calculation part, are you all clear with that? It's a very simple one, isn't it? Okay, so we'll move on with the next one, which is nothing but your bit rates for digital television. So here also we do have something called bit rate. I think you would have heard of frames, number of frames. So based on the frames, the picture quality also does increase, and each the unit of uh, a photo is a pixel. Okay, right. Bit rate for digital TV depends upon the picture format. Okay, one way to estimate the uncompressed bit rate is how many pixels are there in a frame. Okay, so each frame will contain few pixels. Pixels are smallest unit, okay, of probably a photo or a video. It's the smallest unit. So the number of pixels, how many pixels are there in a frame, and number of frames per second. Okay, so this becomes frames rate. frame rate, okay, into number of bits used to encode each pixel. So this encoding, decoding algorithms, all these also plays an important role in your picture quality. Okay, I think you'd have heard of HD, Full HD, 4K, and 8K. These days, there are some contents getting prepared for 8K, but I think 4K is almost available. Okay, but not very much. HD is fully available with most of the service providers, right? So your normal HD is going to be about 720p. Your full HD is going to be about 1080p. Okay, then your 4K is going to be 4 times this 1080p. Okay, and 8K is going to be 8 times 1080p. Now, if you can differentiate between all of this, the major line of differentiation is with the data transfer that happens. Okay, the number of pixels that are there, are in plenty. Now, you can just take the example of your cell phone. When you buy a cell phone, okay, they will say that the screen is about 300 ppi pixels per inch, right? 500 ppi. So as the number of ppis increase, as the number of pixels per inch increases, okay, your screen clarity also does increase, right? Okay. So number of bits per pixel depends on the color depth per pixel. Now we know that we use this RGB concepts, right? Red, then B is for RG. G is for what?
Green and blue.
Red,
Correct.
green, blue, sir.
Correct. So these three are our primary colors. Okay. So using these three colors, we can play around with creating any sort of color. Okay. So ultimately, it's a kind of permutation and combination that happens only with these three colors. Number of bits per pixel depends on the color depth of each pixel. So when I speak of red, so red can have different combinations. Okay, so which means the level of shade, the level of depth can change with each color. And if I mix one color with the other, okay, that brings out another new color. Okay, for example, 16 bits per pixel gives a color depth of 2 raised to 16. Okay, so as your number of bits increases, okay, as your number of bits increases, the number of colors combinations also does increase. So the greater the number, the better. Okay, so these are just like your benchmarks. Okay, the higher the number, the better. So here, this is capable of about 65,000 colors, 65K colors. Consider an example of an HD TV and find the uncompressed bit rate in Mbps if the number of pixels per frame is 1920. See, this is what I was telling you about, 1080p. So which means this is a full HD. So that's why it's called a HD television. Okay, and the refresh rate is about 30 frames per second. Can you tell me what is this refresh rate? These days there are a lot of digital equipments, okay, which are coming up with the buzzword refresh rate. So I think all of you must be aware of it. What is this refresh rate? Can someone throw light on this refresh rate?
Like every time an image appears, for the next image to appear, that particular time limit is refresh rate.
Correct. So is the lower number better or higher number better?
The lowest is the fastest.
Actually, it's the other way around. If the number is higher, okay, it is better. For example, you have the screens coming up with 90 hertz refresh rate, 120 hertz refresh rate, right? So the higher the number, okay, the better or the smoothness, okay, the smooth experience that you can find. So this is nothing but just tricking your eye, okay, the human eye. So how are we tricking this? Okay, if you can probably place a camera in front of the TV, okay, you can see those lines. I don't know how many of you have observed this. Have you observed this? If you place a camera in front of the television monitor, okay, when it's turned on, you can see few lines actually appearing. But with our eye, okay, with our human eye, we will not be able to see those lines. Okay, these are nothing but your frames. Frames are composed of pixels. Pixels are the lowest form of anything. Okay, it can be your picture or it can be your video. So the higher the rate, okay, the refresh time is faster. So which means it is able to switch to different colors. It is able to switch to a different image, okay, without any lag. So these days you can see many of your gaming laptops, okay, do come with a higher refresh rate. They come with about 144 at least, 144 hertz refresh rate. Few do come with even 300 hertz refresh rate. So the higher the refresh rate, the smooth experience that you will find during gaming. So this is a configuration having about 1920 to 1080p, and the refresh rate is about 30 frames per second. One more thing that I would like to say is most of the refresh rates commonly used is about 30. Okay, 30 frames per second. If you see the specifications of your camera also, okay, they would write a video 30 frames per second, or you can shoot in 60 frames per second. Okay, consider a number of bits used to encode each pixel as 16. So they are giving us the number of bits to encode each pixel is 16. So which means I'll be using 16 bits, okay, as my encoding scheme. So now that we have the question here, we will try and harvest this data, and we will try and put it together. So your bitrate becomes a complete multiplication of all. So 1920 by 1080p, 30 frames, and for this 30 frames I have 16 bits of combination. So ultimately the bitrate is going to be 995 Mbps. Okay, 995 Mbps when I multiply all of them together. So the uncompressed bit rate ranges from 118 Mbps for standard television. Now see, when you're watching a video website, okay, you will have the option to change your P, okay, the picture quality. So which means the video quality. So you have 144, right? You have 360, you have 480, then you have 720, then you have 1080, isn't it? So all these values you can actually see and change when you are on a video website. I think all of you have experienced this, isn't it? Yes or no?
Yes, sir.
Yeah. So as the number of pixels increases, okay, the quality increases, and you can actually see that the picture quality, the sound quality also does change, and you can even connect it to a bigger monitor, okay, wherein there is no grainy effect. So when I say grainy effect, when you zoom in into an image, okay, it becomes too blurry, right? So that doesn't happen if the quality is higher, if it's streamed at a higher rate. So here you can see that for a standard television, okay, we need about 118 Mbps, okay, at the lowest resolution, to 995 Mbps for high definition. So if you're just using the normal television, then it would need about 118 Mbps. So see, that's why your service providers to charge you for a higher rate, okay, if you want a higher quality. So why is that happening? Because they have to invest on bandwidth. Okay, why do they want to invest on bandwidth? You can see the differences here. For the high definition, for a 1080p resolution, you need about 995 Mbps, right? But for a normal one, you need about 118, right? So even they have to invest in their bandwidth, and as I told you, bandwidth is precious, right? So the better resolution content, so the higher is the cost. So I hope this concept is clear. Bit rates in digital TV. Yes. Can I move on? Any doubts here?
No doubt, sir.
Fine, thank you. So here, in order to calculate bitrate, we should know in which configuration it is, okay, which is number of frames and number of pixels, okay. So 1920 by 1080p, p is pixels, okay. So that's why I see it says bit rate in Mbps if number of pixels per frame. So this is so this value also you should know, okay. So that comes your number of pixels, okay. So this value corresponds to this, and we should know how many frames, okay. So we know that we are using about 30, okay. So 30 gets multiplied here, and we know that we are using about 16, so 16 also gets multiplied here. So ultimately I will be able to know as to what is my total bit rate for my digital television, right? So this formula is important, okay. You will have to know this formula. Okay, so now you can actually check with the format. Your standard is standard, E is enhanced, HD television, H is high. Okay, so you can see that the aspect ratio changes, and the pixels, okay, 480p, 720, 1080, okay. So resolution. So you can actually see here as to how this resolution of these pixels does change, okay. So 480, 720, 1080, and number of frames also does change, and your bit rate, okay. So it starts about 148, okay. You have 118 here. P is your progressive, okay, and I is interlaced scanning, okay. So you will have to go through this concepts. It's very interesting concepts as to how few are called P, which is progressive type, and the other one is called I, which is your interlaced type, okay. So you will be needing values, okay, ranging from about 118 to 995. So as the number of bit rate increases, okay, so your resolution also does increase. Can someone tell me what is the latest aspect ratio happening in the market? You know what's an aspect ratio? Can I have some responses?
So
18
it
is
is
to
a
9.
proportion of 5 to it, sir.
Sorry?
Uh, it is a proportion of the width and height, sir. Like
Correct.
16
Correct.
is to 9,
Correct.
opposed to 5.
That's right. So now what is the latest trend in the market?
18 is to 9, sir.
18 is to 9, or is it 16 is to 10? Most of them these days are actually going with 16 is to 10 aspect ratio, okay. So this 16 is to 9 has become a little outdated, which means this was extensively used in 2019 and earlier 2020, and the later part of 2020 started adopting 16 is to 10, okay. So a lot of research actually happens with how you are able to view the screen and what is the best height of the screen and the length of the screen, A lot of research happens, and how much your eye can accommodate comfortably moving from one corner to another corner. So based on that, we decide on the aspect ratio. And once we decide on this, your websites also needs to be properly calibrated to support this aspect ratio. Why do you think so? Websites needs to calibrate. Why is it needed? Now, there are two types when you see a website. There are websites developed for mobile phones, and there are desktop sites. So what's the difference between these? Am I asking something new? So the way the information is available on your screen, okay, is different. For example, on our laptops, we have the width to be higher, right? But in our cell phones, the length is higher. So accordingly, the website content does change, and the presentation of the website changes. You have an option even to view the desktop site on your cell phone as well, wherein you'll have to move your screen to the left and right to see the other areas of the website. But if you just see the mobile version of the website, then you don't have to move the screen left and right. You don't have to move the page to the left and right to view the other options. So that's the importance of this aspect ratio. And yeah, fine. So in our upcoming class, we will move on and talk few more points about bit rates, which is actually needed for the digital television. We will even talk of what kind of multiplexing is employed, and in order to change the bit rates, okay, then what is done, what is the application, and we will also look into few research numbers for different types of broadcasting, right? So any doubts, students, up till this concept that we have discussed so far?
No, sir, no doubts.
If you have any questions, then we can discuss. Anything that you want to ask with regards to this discussions that we had today? Fine then. So if there are no doubts, we will probably end our session today, and we will catch up in our upcoming class, and we will try and discuss few more concepts, okay, with regards to bit rate and the other topics as well.